Yeah. So we'll start again. We'll start again. This is good for those just joining. Um, for the sake of recording, I forgot to record at first, but we'll start again. So welcome to the fifth class of African AI, the sixth class of African AI Foundation. This is the start of the series of applied machine learning. In the sequence of this class, for those just joining, because we are going to be working on incremental knowledge. At any point in time, if you have a question or I miss you with a sentence or I say some lingo that you don't understand, please on the chat let me know as soon as possible. I will go back immediately because it is incremental knowledge. So what I will see on the third slide will probably have effect on the sixth slide. So we don't want you to get to the sixth or seventh slide and then get confused, right? So that is that. So go on the chat. You can say question. I will pause, tell you to unmute and ask your question. And if you can type the question, I am monitoring the chat and the slides at the same time. That is one. To move on to the next slide, this is about myself. I have a bachelor's in electrical and electronics engineering, a master's in electrical and computer engineering, and a PhD in electrical and computer engineering. I have a specialization in deployment of machine learning algorithms on resource constrained devices like your microcontrollers, Raspberry Pis, and the likes. I have had um, my experience has been in Venture Garden Group, which was in Nigeria, where I started my career as a business data analyst and project manager. Then I moved to for grad school. I did an internship with Boston Scientific, where they do medical devices, kind of like pacifiers, seizure detectors, where if you're a seizure person, there's an AI that will be implanted that will detect stuff from your brain, from your spinal cord, and help to stop or jilt the body to avoid seizure. And I currently work at Whirlpool, where they make home appliances, oven, washers, dryers, dishwashers, and I help to make the appliance smarter. Peroxide knowledge. So we're back to that side. Yes. So peroxide knowledge. Most of the development will be done in Python programming language, and it because it's peroxide doesn't mean that because you don't have it you can't survive. No, we are going to touch it, but just know that this is one of your first or beginning steps in becoming a world-renowned machine learning engineer, and these are things that are very important. So Python programming language. Now, just picture we humans, we have different tribes, and those tribes come with their language and their culture and their attributes. China, they speak Chinese. In the UK, they speak English. In the English in England is different from the English in Scotland, right? The pidgin in Ghana is different from the pidgin in Nigeria. Same way in the programming paradigm. There's Python programming language, C++, C sharp, F sharp, Go, JavaScript, etc., which you've heard of. But for development in this scenario, there's Python programming language. It doesn't mean there's no machine learning in JavaScript. It doesn't mean there's no machine learning in C++. But we are using of the time worldwide, they use Python for programming language. Algorithms. Well, algorithms is basically if an efficient way of doing things. Algorithms, we have certain algorithms, searching algorithms, different algorithms that can help your work become fast. So if, for example, you are working for Apple and they want you to write an algorithm, and your algorithm is going to take 500 seconds, and another person comes and the algorithm is going to, okay, let me say 500 minutes. Another person comes and writes the same algorithm, it takes 500 seconds. Who would you take? They are both achieving the result, but one is taking longer, wasting more time, wasting more resources. So you need to know how to write efficient algorithms. Data structures. Data structures like lists, dictionaries, um, graph, trees, the best data structure for your data. How are you going to place your data to make you achieve the desired goal in the shortest possible time? So those are kind of peroxide knowledge. And then some of the libraries we'll be using are Pandas, Jupyter, Scikit-learn, TensorFlow. Um, I hope we are with our laptops. Well, you can go back to the video whenever you have with it. Any questions so far? Silence means there's a question. Yes. Is it yes you have laptop or yes there's a question? Okay. So is there a question, Kelechi? No question. So now, prerequisite resources, we are going to be making use of these three resources. Now, some of us already have been introduced to Colab for a bit. Some of us are already making use of TensorFlow. Some of us are already making use of TensorFlow Playground, AI Fido. Yes, those are very okay. Thank you. Those are very beautiful, resources. Another thing we'll make use of Google, Stack Overflow. Please, I'm also learning too. There are times when my code will be terrible. If you can correct it for me, please let me know. I know there are very specialized programmers amongst us. So feel free. It is all knowledge sharing across board. So we'll be using Kaggle, especially for today's lesson. So about the class and the next coming weeks. The next coming weeks, what we're going to do is we're going to build up from the knowledge from Israel's class. We're going to build up, all the things we've learned, hyperparameter tuning, all those keywords, back propagation, front propagation, everything, right? Those are people that want to, if you want to specialize in creating your own algorithm. If you say, for example, the way they are using the algorithm now is very terrible. I want to learn the theory to know how to change the plus to times and change the minus to multiplication, change the coordinate geometry. Good. But there are already libraries that help us put all these things compact that you don't need to do all these things. So that's why it's applied. Straight to the point, no theory. Israel has done a good job of building intuition. We are going to use those intuition to apply them to problems and solve those problems. Please, so far, am I moving too fast? Okay, so now in the sequence, we're going to be moving from regression problems. So regression problems is an AI that takes in numbers and predicts numbers. It can also take in pictures and predict numbers, right? It can, but it's predicting numbers. Regression problems. We are also going to move to computer vision, where it can be from image classification. Show me if I show you a picture, tell me if a car is there, if this is a car, or if it's, what's the car make? Is it Pojo? You understand? We can go to object detection. In this picture, is there an apple there? You understand? Just like you see in the picture, then we can now see image segmentation. Image segmentation is majorly used in self-driving cars, where it will see a picture and it will show that, oh, this is a walkway, these are people, this is a traffic light, this is the road. The road is where I'm supposed to be on, stuff like that. Audio classification. So I've heard Kelechi's voice, Showomi's voice, Josephine's voice. Which one is Tolu's voice? Do you understand? So basically, all we can do bird sounds. Let me know if a parrot is in the air, stuff like that. Text classification and many more. Like for example, when you're watching Netflix or YouTube, it will be recommending a system based on a particular criteria of your choice. Recommender systems. When you go and shop on Amazon or Konga, and it's building like because you search this, you may also want this. You understand? For a while it will personalize itself to you, but it will be inefficient at a while, and then you to keep training based on your choice till or when you are typing a text and you say I am going, and the thing will bring out different words for you. Those are kind of text classification and text captioning, stuff like that. Now that is if time permits. They are beautiful, wonderful projects that we can do. Make sense? Makes sense. So yes, let's whet our appetite on the possibilities of this venture. Right. So I'm going to go to this link, and this is just to show us different machine learning jobs, so that the skills you are learning worldwide is wanted, like in high demand. So I don't want you to have a thing in mind that this is just an online class. Let me just spend 2 hours for free. No, you are needed in high demand. If you notice this is 160 to 200K per year, stuff like that. I want to go through one that has responsibilities, so you will see that um, job description. So you see that all the things you are learning, they make sense. We are going to do LLMs, computer vision, LLMs. Those are things that you can do. So if you look at this job description, Josephine, yeah, who wants to say something? Josephine, please can you mute? Thank you, thank you. I was scared at first. So what I'm trying to look for. I don't write these things well. So you can see, just look at these preferred skills. Deep learning. Deep learning is machine learning. Don't mind them. Data visualization, which you will learn subconsciously using Seaborn and Matplotlib. NLP, we are going to get the text classification. Out of five, you already have three. If you can demonstrate the three, who will not hire you? Right? So this is just to tell you that the skills here. See, can you see? We're going to use scikit-learn. We're going to use Keras. We're going to use NTLK. We're going to do regression. We're going to do clustering is unsupervised learning. I might add that. But all I'm showing you is that this is currently loaded live, job descriptions that need the skills we are passing across to you. You understand? And so it is not out of the blues, or it is not, oh, no, it is something that is in vogue, that people need, people want you, and not just on LinkedIn. Even if you go to Google, companies like this are looking for people like you, at least once you evolve your skills. So basically, this was just to tell you that it takes time to build a skill, it takes time to build a practice. And I was reading an article on LinkedIn that said the more you practice, the more your chances of being lucky. People will say, that guy is just lucky. No. The more you practice, the more your chances of being lucky. So we are going to, and this all everything I'm telling you also goes for me too. So I'm not just talking to everyone, I'm talking to everyone, so including myself. So these are the possibilities, the possibilities of us being at the forefront, the possibilities of us competing with worldwide talent. Okay, I think I'm already moving to the next session. So this is the motivation part. Yes, possibilities of competing with worldwide talent of let's go. We can do it. We can build solutions that from your home by yourself, doing nothing, just knowing the skills you have, thinking through processes, and then we would shock the world. So that's enough motivationals. We are moving to the next section. Python. Python. Now, some people have stated their skills in Python. Some are saying 0/10. Some are saying 2/10. I am a 45-year-old woman working basically as a computer teacher. Is there any chance of me in this industry if I develop my skills? I have a question from Uchechukwu. Yes. You are working as a computer teacher. Is there a chance of me in this industry if I develop the skills? The answer is a big yes. The answer is a big yes. This is a skill that will be around for the next 3 decades. This is a skill that will shock the world. We don't yet even know the impact, positively or negatively. But yes, a lot of millionaires will be made from this industry. So yes, and the beautiful thing of how specific you are, you can either make is there a chance of me in this? Yes, you can explore your chances as a trainer. You can explore your chances as a trainer. You can explore your chances in building technology. You can explore your chances in different ways. For example, someone in the first class, someone said crypto. Crypto is very new, right? AI is very new. What happens to the merge of crypto and AI, right? What happens to the merge of AI and cybersecurity? Everything you think of, go to the mining industry, go to places where they mine gold. What are they doing that can be automated? How can maybe with camera you scan a land, you scan different pictures, and this is just me spitballing, right? You scan different pictures. Is this place? There's gold there. There's gold there. There's gold there. There's no gold there. Can you train an AI that if it sees pictures of a place, it will tell you where mineral is based on maybe how the tree is growing? We don't know. The possibilities currently are endless. It is not a field that is saturated. So yes, to answer your question, Uche, there is a big chance, even if you were 60. right? So, and you're 45 years young. So, I hope I answered your question. So now, what is Python? We want to start with Python. Python is a snake. You are correct. Let's go home. But no, Python is. Oof, wait, hold on. So yes, sorry. So Python is a computer programming language, and the first sequence I want to do is do a 10 minutes run through of Python. Basically, the specifics you will need for at least this class. Now, if you already know Python, people like Sunday that are out there, like, oh wow, Python, we are just going to go through, so you can take a 10 minutes break if you don't want to stay. But I will start a timer in exactly 10 minutes. We will stop wherever we stop. But the collab notebook is very explainable, it's very clear. We're going to just run through what a data type is, what different data structures are, so that when we are using it, using pandas for exploratory data analysis, nobody will be lost. Make sense? Makes sense. So now let's go to, so far before we start, any questions? I know I've not said anything technical, but any questions? That's one. Number two, am I eating the message well? Please, you are my client. I need, can I get some form of validation that I'm doing the right thing? Kelechi, please.
Okay, so good evening, sir.
Good
So I
evening.
don't know if the question is related, but it could have been for Mr. Israel. The
Okay.
assignment that we had, when it got to a point where I have to train the model, and then it was telling me that I've exceeded the faction, and I haven't used any of those, even for one. So
Um, Quick question. What's the data you're training it on?
I was training it on the data was for pneumonia, sir. I was training
Pneumonia.
it for pneumonia.
Do
Yes,
you
sir.
have the CSV? Do you have the CSV of the data?
Let me check. Let me check. Okay, let me check. I followed the steps according to what he taught us. So I
That's
might
fine.
not really get that the
No, no,
question
no,
you
no, no,
asked.
no, no, that's fine. That's fine. I'm going to give you an alternate way on solving it. Now, show me. Do
Okay.
you have a question? So don't, no problem. In this class, we'll get the CSV ready, and then we're going to go run through it. Make sense?
Okay, sir.
Show me. Do you have a question?
Yeah, that's okay. All right.
Okay. No. Yeah. No. Show me said yes, sir. So you can just say yes. I'm not yet this, sir. But um, show me if you have a question. Let me know. If you don't have a question, that's fine. So, but we're going to do a 10 minutes run through of Python. It's going to start from the basic of basics, right? And it's going to move and ramp up steadily. So please pay attention. We just have it for 10 minutes. Okay. So, can everybody see my screen and what I'm showing? I assume yes. Okay. Yes. Okay. So don't worry, I'm also joined in as an audience so I can see what you are seeing. So um data types and operations. So when we were in school, they've taught us, one, what they will teach us is A, B, C, D, E, F, I, T, E, A, T, R, O, N, on. He is on, I go on, am I to go on, right? Queen primer, right? So now, when they teach us that, they also teach us one, two, three, four, five, six. They even teach us that in different languages, on, do, toa, quach, and the likes, right? Same thing in Python, right? What is the first thing they will teach us is 100 times units. Now we have integers. Integers are numbers that do not have decimal points. 4, 5, 8. Integers can be split into odd numbers and even numbers. 2, numbers that can divide by 2 that can be divided by 2 are even numbers. Odd numbers that cannot be are odd numbers, but they don't have decimal points, so they are what? Integers, right? So integers in numbers, like when you're counting all the money you count, they are all in integers, right? So when we have naira like 4 naira 25 kobo, once it is 0.25 kobo is a float or a decimal number. So but numbers that don't have decimal points, like 5, 8, 10, 15, 25, they are integers, right? So you can see we are going through that basics. I know that for most of us this is all common knowledge, but like I said, sharp sharp. Now, float numbers are numbers that have 20 decimal points. 2.5. 3.5, 8.5, 8.5231. If they say pi is 3 point. Can you kindly enlarge the screen? Emma Binu. Is it better now? Is it better now? Okay, okay. Please, like I said, any reservations you have, just let me know. ASAP. Thank you, Avila, for the feedback. So yes, any number that has decimal point, they are known as float numbers. There are times when now, where does this make like where do you need it? There are times when they will give you data, and the person that stored the data will save some integers, some as float. And you are trying to run a code, but your code is confused. Is it integer or float? You might have to cast them and say, oh, make all of them float. So just put 35.0. You can make an integer float by saying if it's 35, just say 35.0. Make sense? So now I am going to see so Python in Google Colab already has made all its code blocks into that you can run Python. So yeah, if I say 4 minus 3, it will give me the answer as what? What happened? It will give me the answer as what? 1, right? Now 2.5 is a float. So now I want to show you something. Let me come here. I'll create a cell. I'll say that answer is equal to 4 minus 3, right? It will not print out anything. If I now say print answer, say it is what? 1. Now let me now show you. If I now ask, maybe I cannot see what answer is. Maybe I cannot see what answer is. And I want to know what is the type. Answer is what type? To determine the answer is an what? Is an integer. Make sense? Same thing with floats. Float is any number that has a decimal point. Now, if I multiply the decimal point by another number and it has a decimal point, that number is still a float, right? So same way, I can say what is the type of this number, right? It will tell me it's a what? It's a float because it has a decimal point. What if now look at this. 2.5 times 2 is 5. It will still give me float because it will see the answer as what? As what? 5.0. So 5 is an integer, but 5.0 is a float. So we can convert integers to float. Make sense? Make sense. Now, float and decimal. Now look at 1 over 3 is what? 0.3333. Now, is that a float? Yes, it is a float. Because if I say type, what will it give us? Float. Any number. So 2 divided by 3 is a float. Now we can, so this is just our board mass. There's brackets, we've done multiplication, division, addition, subtraction. Now we can do raised to power. To write raised to power, this is how we write raised to power. We do multiplication side by side. So 3 raised to power 4 is what? All those that are good in math, 3 raised to power 4 is what? 81. If you not say 81 when I said 81, you need to go and do your times table. Am I correct, Seth? 3 raised to power 4 is what? 81. Good, right? What type would this give us? What type would this give us? All of you are muted. We will not know who said the right answer, but I'm assuming this should be what? An integer. Let's check it out. This should be an integer. For those that already know Python, sorry that we are going this. We want to catch every up. They say a good wave erases all ships, right? Now, for example, pi. Pi is a global standard number, right? Pi is 3.14. Kinikon. I'm a Yoruba boy, sorry, so my tone might grind with Yoruba. So now, pi is 3.14. If I do the type, it will say it's what? It's an int, right? It's my bad. Now, pi, I want to raise pi to power 2. What will I do? Raise to power what? 2. So give me an answer. If I want to multiply pi by 2, that's pi by 2. Make sense? Makes sense. Okay. Square root. There's a trick to square root. Now, hold on. This is very important. Please ask any question. No, Joe. Now, import number as MP. This is a library. There are libraries we need, just the way we have pandas. There are libraries. NumPy is a very good library for numerical computation. It does it very fast, right? So now this pi, I'm supposed to have said, if I didn't want to use it, I was supposed to say pi. I can declare variable. This is a variable name. Pi is what? 22 divided by 7. When they say find the area of a circle, pi r squared. This is 22 over 7. Now, if I do it, now what is pi? Tell me what pi is. Pi is pi is this. But because it's a global number, they already have pi. They already have pi stored in some libraries, right? It's just different based on number of decimal places. Now, what if I want to find the square root? Now, look at how they are using square root. They are using their library format to find square root. So if I did not import numpy, I will not have access to this NP. So when you're in Python, okay, let me go back. Let me go back so that I don't confuse you. We have spent 3 minutes. Now in Python, we can import external libraries, right? We can import external libraries. I can create a library and say Tolu's brain. Now, when you import it, instead of me to be writing numpy, I can give it an alias. So import numpy as np. I can say import numpy as Tolu. If I now come here, any field, I can say Tolu.py. Still work. So you can give it an alias. That's fine. But globally, numpy is always seen as what? NP. Right? So that's that. Now, if I want to find square root, numpy square root is what? 1.7 whatever. I can also write square root like this and say numpy pi. I hope you know raised to power 0.5. I can also write it like that. You understand? So raised to power 2 is square. Raised to power half is square root. Raised to power 3 is cube. Raised to power 1 over 3 is cube root. Raised to power, you get so now, variable assignment. So I can assign variable to variable name. Just the way I did 4 minus 1 is equal to answer. I can assign 1 to answer. So wherever I put answer, it will change. Why that is necessary is because there are times when you may not be subtracting with 4 minus 3 alone. You may be subtracting with a number that is always changing. So say, for example, look at my voice. There are times when I'm talking small and there are times when I'm talking loud. So imagine someone is taking the decibels of my sound. You know that number is changing. So maybe they assign the decibel of my sound to be answer. So instead of me to say, so now maybe the decibel is 0.00 something, the number can be changed. So sometimes you may not be dealing with constant computations, right? So that's why we just need a variable name. So numpy, blah, blah, blah. So we can assign it variable names. We will see all these things. They will come hand in hand. Okay, let's see. Strings. Now, strings. Why is string important? Strings is important because when you are typing stuff in your Excel sheet, when you're typing stuff, you type with words. Why do we need this? Why do we need an alias? I just answered the question. I just saw your question, Joy. I just answered the question because there are times we are going to see it. I'm going to refer to this question. Good question, Joy. And then when I refer to this question, I'm going to call you Joy. If you don't mind me calling your name, I'm going to call you so you can see it. Now, strings. When we are writing in our Excel sheet, there are things called strings. Now, strings are in language. They are kind of like strings are data types for external input. So when we talk to the computer will see it as string. So it can be 1, it can be 2, it can be 3. So it can be anything, right? It can be anything. It will save it as a string. But an integer, it won't save it as an integer, right? Because integer is only numbers. Float is only numbers with decimal points. But string, it will take everything, all and sundry, right? Now, if you want to get length of the string, 15, because if you count it 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, you can get the attributes of the strings, right? If you want to zoom in into each one and say, so say for example, this person is say, like for example, maybe when you were in school, there's course CSC 101, CSC 102, CSC 103. I want to extract all the numbers and remove all the CSCs. You can use string manipulation for that. So now string one. So Python, please. Sorry, I'm giving too much information. Python is zero index. Python is a zero index language. Please, sir, I can't hear anything. I don't know if it's from my side. Please, can everybody hear me? If you can hear me, please, can someone say
Yes,
thank you?
yes, I can hear you, sir.
So
I
Python
hear
is
you.
a yes. So show me. I think it's from your side. So Python is a zero index language. What does that mean? That means that the first character, the first string in Python is seen as zero. So if I say string one, you know the alias is string, right? So it's anywhere it sees st, is seen. Can you see it? Is seen cos one blah, 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 blah. Anywhere it sees st, is seen that cos, right? So now if I say string one, what will it give me? String one will give me, is it C? No, it will give me O because it is zero indexed. That means when I say string zero, it will see C. So string doesn't, the first element is starting from 0, 1, 2, 3, 4, 5. So that means the last one, even though the length is 15, the last one is 14. So that means this is 0, 1, 2, 3, 2, 14. So if I want to say, if I want to get the last four, it is what? 14. If I want to get the 5, it is what? 13. So I can zoom in. Now, if I want to slice, so this one is string 2 will give me U, right? Because it is 0, 1, 2. Please, all these things will be important. Now, there's a shortcut. Since the first one is 0, if I want to go away from 0 to the back of 0, what would I get? -1. It will loop back. So -1 is always the last. Because this is 0, if I go -1, -1 will bring me back to the last. Even though it's 14, -1 will bring me back to the last. Do you understand? So now, so if you look at string -1 is the last term. Is also the same thing as what? String 14. Let me make this very clear. Now, look at what I'm saying. I need to bring this here. Let me bring this here so that I won't be scrolling up and down. So I'm going to bring it here and say this. So look at what I'm saying. Now, this is 0, 1, 2, 3, 4 to 14. But let's say I'm going in the reverse way, in the number line. I'm going the reverse way. This is 0. It will be -1, -2, -3, -4, -5. But it will wrap itself back. So this will be 0, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12, -13, -14, -15. If I say string -15, let me see. I hope you understand what I did. So I can go 0, 1, 2, 3. I can go 0, -1, blah, blah, blah. So this knowledge, what this tells us is that the last term is always -1. The first term is always 0. The last term is always -1. The first term is always 0. So the second to the last term is always -2. The third to the last term is always -3. So because a string can have variable length. So say for example, look at why between string 14 and string 1. So string 1 is -4, is 4, right? String 14 is 4. Now let me come back here. Let me come back here and say this, right? I've increased the string. Imagine the string is changing. If I come here, string 14 will not give me 4. Oh, sorry. Let me change this to. Oh, yes, this is best. Zero index. Let me change this to this. So you can see the last term is 4, right? It's still 4. If I come here, and I say string 14 will not give me 4. But if I say string -1, it will give me 4. It will always pick the last term. String minus, because the first term will always be 0. When you go back, it will always pick the last term. So that's why you need to know -1, and then you also need to know length. So far, any question, please? I think this is the first complex thing. Well, it may not be complex. Good. So now, what is the length of the string? The length of the string. Now, when we did it, what was the length of the string? The length of the string currently is what? 27. If we want to go and get length of string, right? See, now there's something in strings called slicing. There's something in strings called what? Slicing. So let's say, please, any question so far? In the next 3 minutes, I'm going to stop Python, and then any question we can do it and then go ahead. Secondly, if we get to an advanced part and we see that we need some knowledge we didn't get from Python, we will come back just so everybody gets their understanding. So now, we want to slice. So what is slicing? Now look at string. String is cos 1, 2, 3 and gibberish. What if I want cos alone? Course. Cos is what? 0, 1, 2, 3, 4, 5, 5. I can say give me string 0. Will I say 0 to 5? No, I will say 0 to 6. I'll say 0 to 6. So this slicing means I will start from the last first term and I will go to the term from where I will start ignoring it. So string is cos. So instead of me to say 0, 1, 2, 3, 4, 5, I will start from where I want to start from and where I want to start ignoring. Do you understand? So I will go to the sixth one. It will not take the sixth one. It will say everything except the sixth one. What if I want just the numbers? This is 1, 2, 3. So the number is starting from the sixth term, right? The six, 0, 1, 2, 3, 4, 5, 6. So I'll start from 6 and it's ending where? 6, 7, 8, 9, 10, 11, 12, 13. Will I end at 13? Where will I end it at? Please, where will I end it at? Someone should reply in the chat.
6,
It's not 6, so somewhere.
14.
14. God bless you. God bless you. 14. Thank you. This is a good validation that we are in progress. So now, if they want to, this is a way that if you always want to cut off the last term, so this is the part that it will always ignore. If you want to cut off the last term, right? It will always cut off. You can see the 4 is no longer there. If you want to cut off, if you want everything, this is everything. You can merge two strings together. You can merge two strings together with just plus. So this means that if I have a string, now how do you identify a string? A string is usually in quotes. You can see the way we created this string. We put it in quotes. But when we're creating the numbers, we just wrote the numbers like that. Anytime we put anything in quotes, it's a string. So now, if we say this is a string advanced, we want to merge it. We want to merge it with string st, and st is cos blah 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 blah. So now, look at what they wrote. They wrote advanced. They wrote space. They created space and put it in quote. You can also do that. Plus, give me advanced space cos blah 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 blah. Make sense? If I want to do instead of this, I do this. It will do that. You can merge two strings together. Okay. You can multiply strings by 3. So we have cos. It can be cos, cos, cos. So if I say cos, I can say cos plus this, right? Put the brackets. So do you see what I'm doing here? I created cos. Cos, this is st, right? I'm now concatenating it. This is concatenation that we learned here, plus with a space, and now multiplying it by 3. So if you see that, it will be space by 3 and stuff. Now you can find something called SE. If you are looking for a mini string or a substring, if I say find SE for me, it will tell me where it started from. So string, look at 0, 1, 2, 3, 4. SE starts at index 4. So you can see that's why it's returning 4, right? And I think, wait, hold on. I think so far, you can find, you can replace. You can find, you can replace. So what that means is if you want COUR, so you can see COURSE. OURS, we're replacing it with a with an asterisk. Wow, thanks a lot. So that is string. You can split string. You can split it. So look at, they created another string and they want to split it based on this delimiter, comma. You can do that. You can split strings. You can make all of them into capital letters. You can make all of them into smaller letters. That's dot lower, dot higher. So what I want you to do is I want you to um go through this notebook. We'll still come back to it so we can move to other ones. But this notebook is good. Now, to not claim someone else's thingy, I got this notebook from a course I've earlier studied before. It helped me. It helped me in my journey in machine learning. This is a course from Udemy. This is the, if you just take this link, eh, if you just take this link, Control C, and you paste it, it will take you to what the course is about. This is my profile. That's why it's course, but this is some of the things I worked with and I started with. So it's a Udemy. The worksheet is not, primitive to me. It is adopted and adjusted from this course. So okay. So we are pausing on Python basics now. I've used more than 5 minutes. So let's assume we all know some 10 minutes run through of Python, right? So nobody here can say they have zero on Python. No, no, at least you have one or 0.5 on Python. That's the goal of this. Now, we are going to, for those using Google Colab, right? Colab already has some pre-installed libraries for us, so which makes sense, right? Colab has something called Auto EDA. I just found that out, and then to install any library, we just use pip install, stuff like that. If you are using Windows, Windows is going to require you to install a Conda or Python environment, and then from the Anaconda or Python environment, you can pip install. Jupyter Notebook, just like Colab, but Jupyter Notebook is local to your computer and you can pip install. Now these are also resources. You can use ChatGPT to generate codes for you, stuff like that. These are all resources. So say for example, I go to bard.google.com and I say, hey Bard, what's up? What's up? Write an algorithm to find all the even numbers from 1 to 1000 in Python. Bad will write it for you. So in many situations, right? I start, so you can see that he wrote the code for me in Python. I don't know if in case, so bad ChatGPT is not just for typing text. You can write actual codes on there. So many times, I start, maybe I have an idea, I have a rough estimate. Instead of me to invest time, I first generate the code of here. So these are good resources. These are good resources that you can use at your disposal, right? Right, good. We will still go back to Python, that I promise, but let's go because we have a long way to go. So we've done this. Now, after your little knowledge in Python, huh, we need some knowledge in data analysis, right? Some knowledge in data analysis. At least we have 0.5 or 1 in Python, right? We know how to multiply times divide. We know how to do string manipulation there, stuff like that. We'll have gotten to the data structures. There's a data structure part that is crucial. We will still go back there. Now, but let's do pandas because this is crucial to the assignment I will give you. And we are going to do pneumonia thanks to Kelechi. Um, so pandas. And now this is also a long notebook, and this notebook was also gotten from that class too. So I'm referring, so it's a Udemy course. If you want it, you can purchase it. It's just adapted from him to help us achieve this goal. I bought it, you understand. And if you need my login, it's open to all and sundry. So now, pandas, just like I said in. So wait, so far, any questions?
Yes, sir.
Samuel, please.
Hello, sir.
Yes, I can hear you.
Good evening. Yeah. Thanks so much. I actually joined very late because
Okay.
I was trying to charge my phone because there was no light. So, one because I miss out in the beginning of the Python, little basic of Python. But
Yes.
that was why I was trying to quickly go because I have little knowledge of some of the things. But based on what you are trying to teach us now, I was not really connected very well. Then
Okay.
I want to ask concerning the AIF exploratory data analysis. I mean, all this. Do we need to be online for us to do the some of the basic of the Python,
No.
or we can also do it on our system, that's on our local PC?
Yes, you can do it on your local PC. You don't need to be online.
So, do we need to? Is there anything to be installed?
Yes, and that is what I wrote here. Um, so in previous books, we have said these are things with libraries and packages, pandas, typical notebook, Anaconda environment, depending if you are using Windows or Macintosh, Windows or Mac, right? So these are libraries you need to install. These are knowledge you need to have, or little of those knowledge you need to have. These are libraries you need to install. Make sense? So once you have this, now the beautiful thing is that if you just have, you don't need to be online at all, at all. And to install them, I wrote these commands, right? To install Jupyter. Now, if you want to use Colab, Mac, right? And you can use Google. I want to install Jupyter Notebook. If you want to install Jupyter Notebook, so you can just come here, I like using Jupyter Lab. I say Jupyter Lab, install, and then it brings me here to the installation windows, and this is pip install Jupyter Lab or pip install Notebook. You understand? Pip install Viola. It will tell you everything. Make sense? So Windows is a good resource. Google is a good resource. So um, um, so we are back to this place. Now this is supposed to blend us into machine learning from the exploratory data analysis, right? Um, from the exploratory data analysis. Now we are going to start with a case study. We're going to come here, right? We're going to just spy into what is next. This place. We're going to eh, we're going to spy here, and we're going to come here. This is the case study for wine. Now look at, so this is the general flow. So don't get me wrong. We're going to attach knowledge from different aspects, but I'm telling you, at the end of the road, everything will just make sense. When someone says something you don't understand, then after a while, you'll be like, so that's what he was trying to say. Yes, everything will make sense. Just follow my lead. Now, this is Kaggle. Kaggle is a good resource for questions. There are a lot of things that I want us to do. It has a lot of data sets. These are a lot of regression problems that we should be able to touch. Once I teach you one, you should be able to touch two, three, five, six of them. Right? You should, as much as possible. You are that good. Any CV or job this thing they say that regression, they've not born everybody well. You are that good, right? Because there are already libraries that do those things for them. All we human interactions do is that we just go there and we simulate, we run the code, and then we interpret. Right. So now back to red wine. Now, what's the context? There's a data set, they have some attributes of the wine or of the fruit, and then they want us to they want us to please hold on. they want us to predict the quality of the wine. They want us to predict the quality of the wine. So now, in this place, they have a data set. They are going to give us the data set. Now, what's the data set? The data set is what? Archive. I already have the data set. Please give me 1 minute. Okay. So, can you hear me clearly? Can everybody hear me clearly? So, yes, you can hear me clearly. Yes, okay, thank you. So now, back to what I was saying. They will give you a business problem or a problem. Now, look at this. This person has red wine, and they want to determine the quality of the wine, if it is good or bad. If it is good or bad. So now they've given us a data set. Now the data set has these columns: fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free. Now we as machine learning engineers, we have no idea what it is. So most times machine learning engineers work with subject matter experts, right? We just know that give us the features. We will give you a model that will work well. So what they are trying to do, look at the output, they are trying to predict a quality score of, based on this, maybe they give you grape or they give you wine, anything. How will this make a quality wine that people can speak of for decades? So now they've given us the data. We have the data set. So let's go to Google Colab. So as a data analyst, we're like, oh, we have data. Let's go to Google Colab. So we go to Google Colab, right? Now you have this notebook. Now we want to upload the data. We go to data. This is wine quality data. We take the data in. Now, when we take the data in, okay, this is what you learned from African AI Foundation. No? They say that first things first, we need pandas. Now, many of us work with Excel, right? We work with Excel in our offices. Why do we? Because let me show you what the data looks like. The data is like this. It's just like this. We have, can I zoom this one in so you can see? We have wine quality, we have citric acid, residual sugar, we have all these things, right? And it's not that much, but Excel has a limit. Excel can only take up to 1 million data points. After 1 million, even when you're at 600,000, Excel will be hanging, right? So, but pandas can help us analyze big data, huge size of data without much sophistication, right? Now, that is one distinction with Excel. Please give me 1 minute. Sorry for that. Sorry for that little intervention. I just had something to quickly attend to. Yes. So now, based on what you've learned from African AI Foundation, they said let's use pandas. Excel is bad. Excel is bad. So let's use in Google Colab or in your Jupyter notebook, after you've installed it with pip install. Please leave the screen like this for those who will be watching later. Okay, yes, no problem. So now I'm going to you saw how I imported the data on Google Colab. That's it. So first thing I will do is import pandas. When I import pandas, I'm supposed to be able to, read the data. How do I read data? I can read data with this function. So I can say so like just like in Python, we can assign names. So import print panda as PD, I gave it an alias. Globally, pandas I give it alias of PD. If you go to Stack Overflow or Google or you have problem, you see PD, PD, PD. That's usually pandas. So we are following the global trend. PD. Now PD has a sub function called read CSV. It will only read CSV files. So, and look at the file I downloaded is what? .csv. CSV means command separated something. So now, wine quality read.csv. Good. And let me take this off. It has successfully read it. Okay, now, when I read the data, I want to view the data. So I can say df.head. I want to view the data. It is telling me that, I have fixed acidity, volatile acidity, citric acid, residual sugar, stuff like that. So this is, and what I'm trying to predict is what? Um, quality. Yes. CSV means command separated values. Perfect. So far, that's how we read in CSV. Right? Now we can also read CSV and we can write CSV. So after you do your manipulation, if you want to save it back as CSV, all you say is that what's the name of the file? You can name this file anything. It can be wine file. You can name it anything. It is recommended that you make naming convention should be something you can remember. Right? So wine file. Because if I go and I come back, what's df? I don't know. Right? So I can but wherever I see wine file, I will always use wine file. Right? Now, let's create a dummy series. So we can create a series which is just a notebook. You can save it to CSV by doing this. Right? So there's read CSV, there's save to CSV. So to CSV, you can see that it has saved it. You save it with the name, sample CSV, and the index. So it has saved it as a CSV. So you can generate CSV from pandas. You can save different versions of it from pandas. That is one of the things you should know you are capable of in data analysis. Now, that is that. You can also read Excel files. The way there is read CSV, there is read Excel. The way there is, CSV files when you .csv, Excel files when it's .xls. You can also write to .xls. So let me give you an example. Let's say this data, I don't want fixed acidity, and I want to save the version without fixed acidity. So I want to edit the data and save it. So I can come here. Come on. Okay. I can come here and I'll say wine data is equal to wine fine, which is the one that I've read. Dot drop. Okay. Sorry. Good. So now I have dropped a column. So if I say wine data dot head, right? If you look at wine fine. Wine, I wanted to type fine wine. It had fixed acidity, right? But now I have dropped a column. Now this one does not have fixed acidity. Now I can now save this one and say wine data dot to CSV, right? Right? And if you look at this directory here, something is going to pop in and say wine data. It's still loading. You can see it. So I've created a new CSV from that. So you can read CSV, you can write CSV. This is supposed to be another 10 minutes. You can read Excel, you can read JSON. So I've just written the syntaxes for that. Now, let's assume that you have a series. So let's just go this panda. So now this is called a pandas data frame. This is called pandas data frame. Many people used to use data frame as DF. So that's why you see a lot of people will say DF. Now, you come here. Now, look at this series. We generate some random numbers, 6 random numbers, right? When we generate 6 random numbers, we can write them as a dictionary. Good. Now, I'm saying a new keyword, a dictionary. A dictionary is a data structure. A dictionary is a data. With time, we will get to adjust this. Don't worry. And please, you have a question. Kelechi, please, what's your question?
Yes, sir. So the question is that when you drop the phase acidity, will the original data set still be there? Will
Yes.
it alter it? Like I'm saying
No,
that
no. So
other
if you
ones
look
are
at if you look at this, so 7.4, 7.8, 7.8, 0.7, 0.88, 0.76. Look at it. Let's look at wine data. Sorry. I'm going to comment this out and I'll say this. Now, if you see, let me just reduce it. So you can see 0.7 is still 0.7 is still 0.7. 0.88 is still 0. Nothing will happen to the rest. If anything happen, come and call me. Nothing will happen to the rest. It will just take what you said and get it off. Do you understand? I hope I've answered your question. So now this is a
Sorry,
series.
Mr. Tolulope.
Yes.
Sorry, maybe if I could add a little more to Kelechi's question. She's curious to find out
If what? If can anybody hear? Okay, I can't hear you. You disconnected for a while. She's curious to find out if.
Okay,
Hello?
I think I might be having a network problem. Let me type it. Please continue.
Okay, please. That's my Oga. So now there's something called dictionary. Now, dictionary is probably the most beautiful, to me, the most beautiful data structure ever to be discovered. Now, why is dictionary good? Dictionary is good because it has something called key value pair. It's a hash map. Some people it's also called hash map. Dictionary has key value pair. Now, if you go to the Python notebook, towards the lower part, we're supposed to talk about dictionary, but it has something called key value pair. Key value pair. Now, what is key value pair? Just imagine what it is key. It is a key to a particular padlock. That key is guarding a value. Now, if you look at this, the key value pair here is that the key is A, the value is 6. So if I want to have 6, all I need to have access is A. The key, it can be anything. The key is B, the value is 3. The key is this. So look at this. Now they created a dictionary. That dictionary, you can convert it to a panda series, which they did. You can also convert it to a data frame, which they will do. This is another dictionary. So let's get back to the question. Kelechi, the data has been loaded to the RAM, and that's the one that's been manipulated. The original. Okay. The original data sheet. No,
I
that
think
is
he
not
actually answered the question. I
okay.
think he did because I wanted to know if the original data set will be
Will
kept,
not
even
be
though that
tampered.
other one.
No.
Okay, thank you, sir.
No. Wait, just to go back to your question. So look at this. This is the original file from CSV, right? This is the original file. This is it when I loaded it, right? Now, if I come and I say, if I don't save it, nothing will happen to it. It will only happen to this instance. We have created an instance of that file. The original data will still be there. If I don't save it to CSV and overwrite that name, nothing will happen. Right. So thank you, Israel, for catching that. So now this is a dictionary. You can convert a dictionary to a series. You can also convert a dictionary. So this is also a dictionary. This has a string and a PD series. Right? This has a string. So now you can also convert it to a data frame. So you can see PD to data frame for a dictionary. You can also say PD to data series. Right? PD to data frame D. PD to data frame D. Okay. Sorry. Hold on, give me 1 minute. So now this data frame has a series of, so this is how key value pair is interpreted into data frames. You can see this column is serving as this column. This, whatever is there. So if I had written A, it would have turned to A, column 1, column 2, right? Column 2. So we can convert, this is also a dictionary. We can convert it to a data frame. Now, this is just the same way. This has 3 columns. You can convert a dictionary to data. So now we are entering something called data structures. Now this is a list. This is a dictionary. This is a list. There's list and there's dictionary. And now they are combining into data analysis. Now we are going to understand what list is, and then we're also going to understand what dictionary is. I just want to pass across some things as regards exploratory data analysis. So we can convert a dictionary to that. But usually, when we read our file, our raw file, it is seen as a data frame already. So now if we want to access column 1, we can just say df column 1. So if we want to access column 1, if we want to access column 2, we can just say df column 2. It will take AW8TY. If we want to access column 3, we can access column 3. Hold on. Yeah, we can access column 3. Right? If we want to access column 1 and 2, now look at the difference. If you want to access one column, is 1 bracket. If you want to access 2 columns, you have to put 2 brackets. More than 1 column, you have to put 2 brackets. This will also work for column 3, right? But if you want to do 2, it has to be basically and everything as a string. And get to columns, which is what was achieved here. Right? Good. Now, there are basic commands, location, iLocation, right? So now I'm accessing them as a whole. What if I want to access a value itself? So I want to access this 1, or I want to access this AW. Maybe it is a bad value. I want to change it, or I know the original value and I want to change it on the go. I can access it. So if I say df.iloc1, you can see the location is 1. The location is 1, so that means that the value is 2 and 8. 2, 8, and 5. This is for column 3. Still checking column 3. So if I want df.ilog0, ilog0 will give me what? It will give me 1 AW and 4. 1 AW and 4. Right? So it's just to access specific ones. Right? Now, if I want to add new columns, I can easily add new column 1, column 2, column 3. So I will encourage everyone to, go through these notebooks and ask any questions they want. I would encourage everyone to go through these notebooks and ask any question they want, so that we can do this offline and it can accelerate our learning process. Right? If I want to delete a column, just like I did earlier, I can drop a column. Right? So all these are specific commands that, as you are looking at the data sheet And as you are following the flow, you can see what is happening to the columns. Make sense? Makes sense. So, do we have access to the notebooks? Yes. I am going to make it accessible through a link. Where is it? And I'm going to copy this on the group. Right? Only people that have access. So I'm going to make it accessible and I'll send it to the group. Right? So you can just go through it. And the next class, the first 20 minutes will be that when I was going through this notebook, did you have any problem? Did this happen? Do you want me to explain this? And then we'll go through that. Make sense? So I want us between now and the next 10 minutes. So in the next 10-15 minutes, the rest will be I'll go through a machine learning problem with everything we've learned. We are going to add everything together. If you understand, if you don't understand, jama. We are going to add everything. We are going to get it. And then once we do that, we're not going to come back next week, go and digest everything from every notebook, and now come and let's ask questions. The first 30 minutes will be devoted to asking questions. Right? So now we're going to pause here. This will be available for everybody on Telegram and on WhatsApp. Right? So I will pause here on exploratory data analysis. First and foremost, always know that after the class you have to practice for you the understanding to stay. We can't teach you everything. I don't even know everything. But one step at a time. So now let's solve that problem. Let's solve the red wine problem. Let us solve the red wine problem. But before we go into that, what is machine learning? Machine learning has a life cycle. They give you a business objective, you do the data gathering, data preparation, exploratory data analysis, you build the model, you evaluate the model, and you deploy the model, and it goes on and on in that cycle. 80%, Mr. Ezra said something in the first and second class, 80% of work has to do with data. So exploratory data analysis is very, very, because that data is very important to, that data is very important to understanding and building your model. So now we are going to, I'm going to show you some that I accumulated. This is another notebook for classifiers. So basically, if you want to use different algorithms, I'm going to show you how to use one algorithm. So if you want to use Gaussian algorithm, this is the syntax. If you want to use using sklearn, everything we're doing, decision tree, this is the syntax, random forest, extra trees. I've from past classes and past this thing, we've compiled some algorithm that just copy and paste straight up. You don't need to, of course, you need to understand, what the code is doing. Please, that is what is going to stand you out from being good and being, special in this field. You need to understand everything. So this is a model that if you pass your notebook and you're saying, I want to work with k nearest neighbor or random forest, what does it do? You just copy this part of the code. Once your data is prepared, finish. You need to train your code. So now let's do one exercise on sklearn. When we go next lesson, we're going to come with your questions, come with your problems. I'm not a pastor, but come with your questions and then we will solve it and walk through, right? So now let's go to the next one. The next one is, let's solve a question on red wine with sklearn. Let's solve the question. Let's assume the business objective of the company is that, I need red wine. They've given us this data. What can we do with it?
Sorry, sir. Hello, sir.
Yes, please.
Sorry, I just have a question, please. I
Yes,
want to ask, the Google Colab, do one need to register, or is it free, or one we have to get to premium? Like there's the ChatGPT that you mentioned. I have one ChatGPT that I installed on my device, but there are some things that I want to do. It's telling me that I should go to premium. So I don't know whether the one I downloaded is not the correct one.
So usually for ChatGPT or for Bard, I have not downloaded any one, right? I just go online and I use GPT-3. GPT-4 you need to download. That is one. You can use Bard, you can use Claude. There are many ones that are free and open source. and as equally as good. And I don't know if you've discovered that your Chrome. So I'm looking at my Chrome now. If I say it's not the right ChatGPT, right? Yeah, it's not yet. Okay. Don't feel overwhelmed by non specific comments. So if I say Wahala, right? I hope you know there's now like a ChatGPT on your Google Chrome that helps you, that helps you generate anything. Like if I say write write a C++ code for me, ChatGPT is now, or a GPT is now directly on your Google Chrome if you've upgraded it, and it will generate for you. So GPT is becoming very well open source, that you don't need to pay for anything. Bard is free, so that's that. Number two is Google Colab is free for everything we are doing so far. Is free. You don't need much resources. So far, you have a Gmail account. Register with your Gmail and open a notebook, or upload a notebook, or make a copy of a notebook. You are fine, right? So that, I think, has solved your answer to your question. So now we want to solve the find my problem. Find my problem is that giving some acidity or attributes of some fruits or some product, what is the wine quality good or bad, right? So let's assume that we know 0.5 Python, 0.5 EDA. Let's work on something. So what will I first do? I first need to upload my data. Okay. Terminate. Terminate. Okay. So he's just complaining that I have different notebooks open. So now, if I want to upload my data, I have uploaded the fine wine data, right? Now, I want to, these are necessary libraries I need. Now, if you are using your Jupyter notebook, you would need to, you would need to, you will need to install these libraries, but Google Colab already have them pre-installed, so I don't need to install them. So it's just the pip install pandas, pip install numpy, pip install the seaborn and the likes. So this. Now, just like we did, I want to read the CSV file. I will read the CSV file. Now I've read the CSV file. I want to check what is inside the CSV file. File.head, right? It's telling me that I have fixed acidity, volatile acidity. Now there are some questions you should always ask, because every problem, so far you understand it and the features are there, they follow a general approach, except some specific ones. So now there are some things you want to, let me close this here. There are some things you want to have, like these are all the features. Usually all the columns of your notebook are the features you have available to you, right? So now the columns, these are the columns, right? So if I want to check the columns are fixed acidity, volatile acidity. Kelechi, please, what's your question?
So
Kelechi?
before I got disconnected from the network, there's a part where you said you import a data. In a situation there is no existing data, but you are asked to like predict what the model is. What will you do?
The model cannot work if there's no data. That's why the first thing is you have to gather data. First thing is you have to gather data. So if I come to you, Kelechi, if I come to you and I say, if you go to ShopRite, tell me the top 5 things people buy. What are you going to tell me? Kelechi, I'm asking you.
Bread.
How? What's the evidence? Can I quote you on this? No. You are going to tell me that you need the data to study it.
Okay,
John,
sir.
you need it because you don't. You are guessing. You are, maybe you've seen some news article that it's bread that they buy the most. You are guessing. You understand? What if it is Hamlet? What if it's this? If we argue it, it's the data that will dictate it. So first things first, you need data, right? And that's why they say data is gold. Now, these are all the features I have to predict quality. These are all the features I have to predict quality. Okay, so now I want to use lists. I've created I have something called I have a data structure called lists. Now I want to convert all those columns to a feature for my machine learning. This is what I'll do: lists, file dot columns. I've converted it to a list like that. So now we're going to use these features later, but first we want to do, they've given us the data. We don't know if the data is clean or is dirty or is terrible. Let's find some insights from the data. The first thing I will do is I will say file.describe. So now, why is it file? Because when I opened the data, I started the name with file. If you had used wine, it will be wine, 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 wine. That name is very general, is specific to what I use it for. So now file.describe. When I say describe, right, they are telling me that all fixed acidity has 1500 rows. 1500 rows has values. So this is telling me that there's no missing data because all of them have 1500 or 1600 values. All of them, for every row, the whole row is 1600. The whole row is 1600, and these columns, all of them have values. So there's no missing data. Right? So if it's that this was 1500 and this was 1700, that means this is missing 200 values. That's one. The mean across all the 1600 values is this, the standard deviation is this, the minimum value is this, the maximum value is this. So I know that fixed acidity is from 4.6 to 15.9. This is very acidic. Volatile acidity is from 0.1 to 1.58. You understand? This is 0 to 1. This is this, something like that. So this gives you a description of the data you have across all the columns. Now, I want to ask, is there any value that is missing across the whole data set? That is why I'm using file. You know, file is the name of all the old data sets. File is the name of all the data set. That is any of them null? Is there any missing value across board? If there any, it's telling me false, which is evidence from this description. So go through the notebook and study it. Now, the next thing is, what if, this is just my own writing. I'm writing with a loop. So if you notice, every feature is now every column is a feature. Now, those features, I want to now investigate them individually, that maybe this one did not see anything. No, let me double check. So this is now saying that for every feature, so everything inside feature, what is inside feature? Fixed acidity, volatile acidity, citric acid. For all of them, I want you to check if there's any value missing in them. So this is what I did. So it's going to check fixed acidity. It's going to check if there's a null value there, and it's saying that it's false. It's me that wrote this one. If I write equal to here, it will change to equal to. This is a string. Anything I write there, I can do this and this. It's just to make my doing artist. So something like that. It's just to make it more visually appealing and readable. So it's telling me that across this, there is no null value. So we've done like an overview of what our data looks like. There's no null value, there's no missing value. Good. Now, what is the graph? What does it? So you now have to visually check, because from the numbers, you don't know if your data is appealing. What if there's an outlier? You now have to visually check. Okay, plot everything together. This is what it's plotting. It's telling me that this is the graph of quality. Quality is just between this value, because you can see some numbers are up to 300. Quality is just here because quality, the highest value of quality is what? Quality is between what? 3 and 8. Quality is between 3 and 8. So on this scale, it will just be between 3 and 8. Okay, these are all these values, right? Now, what if I want to plot them individually? So I can say volatile acidity, plot it. This is volatile acidity, plot it. I can say fixed acidity, plot it. Fixed acidity, plot it. I can say fixed acidity, plot it. I can plot each of them. You know, I plotted everything together, and I want to be plotting them one by one, right? Now, just to be sure that my data, they all follow the same approach. But now, I want to ask you something. Don't you feel that this... I want to ask you something. If you look at this citric acid, look at all of them. They all fall in this range. Don't you think that this is an outlier? So I want to check which one is this one. Which one is this one that is very close to 1? I will come and check it out. Tell me, I will file. Tell me which part of citric acid is equal to 1. It now brought this one out. This is the one, no, the one that you think is an outlier. This is the one that citric acid is 1. Do you understand what I'm saying? So this tells you that maybe there's someone that entered the data wrong, Or maybe, is this a problem that is taking us through? Okay, sorry. So now, for example, if you look at this one, I will not see this as an outlier because there are 2, 3, or 4 of them that are lying in the same space. I won't see it as an outlier. Now, in this scenario, I can see this as an outlier. Kelechi, please.
So please, I hope I'm not slowing down the class.
No,
I
no,
just
no,
wanted
no,
to.
please. Because the questions you have, other people may have it.
Okay, sir. Okay, what I wanted to ask is when you said when the columns are all even, there's no missing number. Does that mean that the data is cleaned and structured?
No. It
Okay, sir.
means that, for example, just imagine that one of the accountant or the person forgot to enter this number here and it's just blank. It's just blank. This will have read it in the description. Sorry. Let's say it's just blank. In the description, this will have said 1598. Do you understand? You can see all of them are saying that the count of all of them that have value is 1599, 1599, 1599, 1599, 1599, 1599, 1599. Right? If it was now 1598, one of them is missing the value. Do you understand what I mean? So now, I hope everybody gets that clear. Um, so
I have a maybe I don't know if this is what she's asking, but the fact that there's no missing values, which is not always typical, doesn't mean that maybe someone has gone in and imputed values for potentially missing values. Maybe that's what she's asking, so that the data has been cleaned and there's no missing value because you've either maybe imputed a 0 or something for supposed missing values, or you've done something to remove missing values.
yes, yes. So to answer that question, right now, in many scenarios, say for example, there's a missing value, right? There's a missing value. There are different approaches to it. Some people will say there's something called fill now. There's something called there are approaches to replacing some people use moving average to replace those values. But in this scenario, if it is all complete, right? All complete, it means there is no missing data. Missing data does not mean there is no outlier. It does not mean you don't need exploratory data analysis. You still need to explore because if someone just put another data and say yesterday was 0.5, today is 0.5, you understand? We can see some some irregularity in the data based on the graph and the behavior over time. So because there's no missing data does not mean you still need to do your exploratory data analysis. Make sense? Who was that talked? I think Joy. Thank you, Joy. So now, just the way it is, you can see there's no missing data, but we are from the graph, we are noticing some outliers. Yes. Inyolua, you're right. So this data is gotten from Kaggle, and it is for most of the times the data analysis or the data is already prepared well for us. So most likely this data is going to be structured. Most likely we are not going to face a lot of headaches in exploratory data analysis, right? But in usually in fields, data analysis usually is a headache. So that being said, so this is how I spotted one of the outliers. In this scenario, you can see this is the only one that is standing out. I'll just take volatile acid is greater than 1.4. I don't know what this value is. I know it's not 1.6. I can go and select it and say volatile acidity. Tell me the place where volatile acidity is greater than 1.4.
Sorry, I don't know if you've noticed the meeting said it's closing in the next 4 minutes. Are you aware of that? Maybe it's an error, so that it will be corrected.
Yes. Okay. That being said, now one question that is telling you is that one question that should come to your head is what if we have 1 million features? What if we have 1 million features? We will not tackle that today. But what if we have 1 million features? Are you going to print 1 million graphs? So that it's tackled in this notebook, but we will do it. So this is a simple code for training with machine learning using sklearn. We are going to train regression to determine quality. Now, if I train it, it's telling me that I have an error of 0.35. I have a mean squared error of 0.35. This is a very good model. Now, what that means is that now if you look at what are the features it used, X. So what I did was okay. Let's try and see what we can do in the next 5 minutes. I'm going to share this notebook so you can go through it using sklearn. So what I did was file is file. By default, I drop null values. This is drop null values, but there's no null value, so it won't drop anything. So I created a copy of the file, and I dropped quality. So I'm trying to do features, or I can just say so the features I have, in case I can please delete to reconnect. Yeah, this is features, right? Now, features is what I want to use is the features I want to use, and quality is what I want to classify, is what I want to determine using these features. Now, that's why features is here, quality is here. Now, if you look at what is features, features is every column. Features is every column except quality, because that's what I want to use. This is already a structured data. Every column except quality. I'm coming. Right? So now that's why I am dropping quality. I'm dropping quality from everything. So features, then there's something called test train split. Test train split. There's a library called test train split. What that does is it splits the I have less than 3 minutes. Okay, sorry, I got carried away. So let's do this. We're going to stop the meeting now. You can sign in again. Right? So we'll stop the meeting now.